Hello dear students, myself Dr. Shreya Mehta. I am taking your elements of mechanical engineering. In today's lecture, we are going to discuss about new chapter, that is refrigeration and air conditioning. Refrigerators, all of you have seen. Sometimes you might have question also to yourself that how it might be working, what is the mechanism. So today we are going to learn most popular topic all of you now need, that is nowadays I can say that air conditioning, all of you, majority of the people are using the air conditioning, and in the present scenario of global warming, air conditioning has become a necessity for some industrial processes also, and for the human comfort level to work in a different conditions. So all of you have seen, all of you are using the refrigerator as well as air conditioner. So word is not new for you. I am sure all of you have seen the refrigerators and air conditioner. So today we are going to discuss about this interesting topic, that is how refrigerators are working, how air conditioners are working, what is the mechanism behind it, how we can improve the performance. So let's discuss. And again I would like to mention over here that don't think this particular topic, that is refrigeration and air conditioning, is included in your elements of mechanical engineering subject that is taught by a mechanical engineering faculty, but it is necessary to know the mechanism by all the people like instrumentation and control people, because they are going to use this pressure measurement, flow measurement as well as temperature measurement in the various HVAC system. And of course for the electrical engineers also, they are going to use this type of wiring system they are going to do in a centralized air conditioning molds and all that. So for the electrical engineers also, it is necessary to know the mechanism how refrigerators and air conditioners are working. Another thing, for the computer and IT people, they should know, because they are going to develop the software for automatic control of different large cold storage, that is refrigeration plant, and large centralized air conditioning plant. So although it is included in your elements of mechanical engineering subject, but all of you should know at least fundamental the mechanism, how it works, all the refrigerators and air conditioner, how they work. And it will be interesting also. I hope you will learn a lot in this particular chapter. So in this lecture I am going to cover, this is introductory part of the refrigeration and air conditioning chapter. What is the refrigeration and refrigerating effect, methods of producing the refrigeration, main components are used in refrigeration system, how the refrigeration is produced, refrigerants, that is working medium used in any refrigeration system, vapor compression refrigeration system, advantages and disadvantages of vapor compression refrigeration system. So in today's lecture, mainly the introductory part we will learn about, and fundamental details, how in olden days how the refrigeration were produced, and what are the different new developments of producing the refrigeration. So let's start our interesting topic, that is refrigeration. Today we are going to mainly discuss about the refrigeration part, and in the next lecture I can say that we will continue on air conditioning. So our today's focus will be on the refrigeration part of this particular chapter. Now I would like to say that I would like to give you one example, that here say one substance is at a 5 degree centigrade temperature, and that is a substance A, and another substance is at a 10 degree centigrade temperature, that is a substance B. So heat will flow from which, A to B or B to A? So immediately you will say that heat will naturally flow from 10 degree centigrade to 5 degree centigrade. Heat will not flow from 5 degree centigrade to 10 degree centigrade. So if I want to cool this 5 degree centigrade to 2 degree centigrade, then I have to apply the work. So heat always flow from higher temperature to lower temperature. In order to move the heat from lower temperature to higher temperature, some external power must be provided. So I would like to say that all the refrigerators are power absorbing machines in which we are producing or we are moving the heat from lower temperature to higher temperature. So according to the second law of thermodynamics, heat will not flow from lower temperature to higher temperature without aid of external power. So if you want to move the heat from lower temperature to higher temperature, in other words, if you want to cool the cold body and move heat to the hot body, you need external power. So all the refrigerators are power absorbing machines. They are working on second law of thermodynamics. So basic principle of refrigeration is the second law of thermodynamics. Heat will not flow from lower temperature to higher temperature without aid of external power. Here with the schematic it is represented. This is a low temperature reservoir. This we want to maintain at a lower temperature. So we need a refrigerator, and the heat extracted is supplied to higher temperature. So whatever the heat is absorbed from the low temperature reservoir with the help of refrigerator is rejected to high temperature reservoir, and for that we need to supply the work input. So I would like to repeat, refrigerators are power absorbing machine working on second law of thermodynamics. So refrigeration means producing cooling. Refrigeration means cooling, moving the heat from lower temperature to higher temperature, and for that we are supplying the power. So machine, mechanism which will absorb the heat from the lower temperature or low temperature or cold body is the refrigerator, and that refrigerator is our machine. By absorbing the heat, it will produce the cooling and supplying that absorbed heat at a high temperature reservoir. Now, in exact definition of refrigeration, so process of removing the heat from the space or substance to be cool to reduce its temperature and transferring that heat to another space or a substance. This process is known as refrigeration. And what is the refrigerating effect? That is, it is the amount of heat that is removed from the space or substance to be cooled. That is, whatever the amount of heat that is removed from the space or substance to be cooled is a total amount of refrigeration effect that is produced. Now, how we can produce the refrigeration? What kind of mechanism? I mean, it is a machine. Refrigerator is a machine. what are the different processes by which we can produce with the help low temperature with the help of that machine. So let's see one by one different concept in which by that concept we can produce the refrigeration. So first is evaporation. What is it? Evaporation means, suppose I am having a liquefied gas is there. I want to produce the cooling, so I will supply this liquefied gas to a space to be cooled. It will absorb the heat from the space and this gas is evaporated. So by evaporation of these liquefied gases, by evaporation of liquefied gases, we can produce the cooling effect. So first is evaporation. Another example, if I would like to mention over here, this is the first example. In the evaporation of liquefied gases, we can use the LN2, liquid nitrogen, liquefied O2, LNG, liquefied natural gas. We can use all this. By evaporation of these gases, we can produce the cooling. While in the second case, simple example of day-to-day life, if you are coming out from the say swimming pool and the water inside the pool was at the same temperature of your body temperature, so what will happen? As soon as you come out of the swimming pool, the water which is present on the body surface, that will absorb the heat and you will feel that gets evaporated. That water gets evaporated by absorbing the heat from the body surface, and that water gets evaporated, so you suddenly feel cooling. So by evaporation of the liquefied gases or by any evaporation of the water which is present on the surface or your skin of the body, and by absorbing the perspiration, that water gets evaporated. So this is one concept by which we can produce the low temperature, that is by evaporation means absorption of the heat. So some fluid is evaporated by absorbing the heat and produce the cooling. So one concept of producing the low temperature or cooling, that is evaporation. Second is expansion. Expansion of the gas. Expansion, now all of you are knowing that suppose if I am having a gas in a piston cylinder arrangement, some gas is available at a say 10 bar pressure. Now if I move the piston and this gas will expand, so the temperature will move. So pressure is directly proportional to the temperature. So pressure is reduced, temperature will reduce. So by expansion of the gases, we can produce the low temperature. So first is evaporation and second is expansion of the gases can produce the low temperature. So with the help of this concept, that is expanding anything from higher pressure to lower pressure, we can produce the low temperature. So expansion is another phenomena by which the temperature is lower down, and that temperature, at lower temperature, whatever the gas is available, that can be used to produce the cooling. So first is by evaporation, the absorption of heat taking place. Another way, the expansion of the gases. By expanding the gases, temperature and pressure both will reduce simultaneously, and we can get the low temperature gas which can be used to produce the lower temperature. So that is the second way. Then thermoelectric, all of you have heard this word, thermoelectric refrigeration. So thermoelectric refrigeration, I am just describing the different methods by which you can produce the low temperature and refrigeration. So thermoelectric is another way by which you can produce the low temperature, and all of you are knowing about your 10, 11 and 12 standard level. Two dissimilar metal, and if they are joined, then at one place an EMF is passed through the junction. At one junction is maintained at a lower temperature, and at another junction you get the higher temperature. So this junction of a two dissimilar metal, and if EMF current is passed through this, then the one junction can be maintained at a lower temperature, and another end you can achieve the higher temperature. This is one way of producing the cooling, and sometimes it is used to cool the microelectronics part. Then steam jet refrigeration system. In the steam jet refrigeration system, the concept is used, generally water boils at 100 degrees centigrade. Generally water boils at 100 degrees centigrade, but at atmospheric pressure. At atmospheric pressure. But if I am having a closed container in the water, and water is filled inside the closed container, and if I maintain the vacuum on the surface of the water, if I maintain the lower pressure, vacuum means pressure below the atmospheric. So if I maintain the lower pressure, I make the water to boil at a 5 degrees centigrade temperature. So I will have a chilled water. Chilled water is available if I maintain the lower pressure at the surface of the water. So water boils at 5 degrees centigrade temperature, and chilled water is available to produce the cooling. So this is another way that water generally boils at 100 degrees centigrade temperature at atmospheric pressure, but on the water, if you maintain the vacuum, that is pressure below the atmospheric pressure, then water boils at a 5 degree centigrade temperature, and for the boiling it will absorb the heat from the water itself, the remaining water itself. That's why we are getting the chilled water, and that's how we can produce the cooling. So that is known as steam jet refrigeration system. Then vapor compression and vapor absorption refrigeration system, that you are going to learn in detail about the vapor compression refrigeration system and vapor absorption refrigeration system. But before that, I would like to mention few things over here, that new development about the refrigeration system is the thermoacoustic refrigeration system. That is, lots of research is going on, and we are getting the low temperature by thermoacoustic refrigeration system. We are just maintaining the two end of a hollow tube at a different temperature, and sound wave is generated, and that sound wave will produce the cooling, that pressure oscillation. And another way we can say that if you supply the sound wave, and we can have a temperature difference produced in the hollow tube. So sound wave can be converted into the heat wave, and that way we can produce the low cooling, that is lower temperature can be achieved. Lots of research is going on this particular area. This is just for your knowledge, that this is one of the method, that is thermoacoustic refrigeration system is one of the upcoming method, new developments of producing the refrigeration system. And another thing is mixed gas refrigeration system. That is mixed gas refrigeration system, in which more than one gases are used, and we can produce the cryogenic temperature range, that is very very low temperature we can produce by simple component which are used in our domestic refrigerator. So that is also upcoming field. Lots of research has been done in this area also. So these are a few methods by on which lots of research is going on, and that is just for your knowledge. I would like to tell you that in the field of refrigeration there are new technology as well as new methods. By sound wave we can produce the refrigeration, and by mixed gas refrigeration system, very popular system on which research is lots of research has been completed, I should say, and they have come up with the good solution, and we can produce the cryogenic temperature by mixed gas refrigeration utilizing the same component which are used for the domestic refrigerator. So I would like to mention over here that the same compressor can be used to produce the very very low cryogenic temperature range by if you use the working medium as a mixed gas refrigerants. So let's continue. First thing, that vapor compression refrigeration system, that we are going to learn in the detail about this vapor compression refrigeration system. So we will see what are the different components of the vapor compression refrigeration system and how the cooling is produced by vapor compression refrigeration system. So let's discuss now in the detail about vapor compression refrigeration system. So first we will discuss that why it is vapor compression refrigeration system. Why it is vapor, why not gas refrigeration system or not air refrigeration system, and why vapor compression refrigeration system. So that we are going to discuss about the air refrigeration also. As I have told you that by the expansion of the gases we can produce the low temperature. So similarly, if we expand the gas, we can expand the air which is easily available and which is at a free of cost, I can say, which is easily available and available at a free of cost. By expansion of the air, we can produce the lower temperature. So air refrigeration is also one possibility, but then why we are learning about the vapor compression refrigeration system? So I would like to say there are few disadvantages of air refrigeration system. So before starting to the vapor compression refrigeration system, I would like to mention over here the why vapor, what are the advantages and why we are learning the vapor compression refrigeration system. So first disadvantage of air is it is not changing its phase. Phase change is not occurring in case of air. So total amount of heat absorbed by the air is less. Total amount of heat absorbed by the air is less. Second thing is air. So here how I can explain you this total amount of heat absorbed by the air is less. Why? Because air cannot change its phase from vapor to liquid and liquid to vapor. Air cannot change its phase to vapor to liquid, again liquid to vapor. Air cannot be converted into the liquid form. So the latent heat, that is total amount of heat, is sensible heat plus latent heat. So this latent heat part is totally absent in which air cycle refrigeration system. So total amount of heat that is absorbed by the air is less. So only sensible heat will be absorbed by the air. So in the case of air, only sensible heat is absorbed and no latent heat is absorbed by the air. That's why the air cycle refrigeration will not produce the lower temperature. Second thing about the air is that total volume will be more. So for the air cycle, total volume which is to be compressed, that will be more for given temperature, for producing given refrigeration effect, for given refrigeration effect. So the air required, that is total amount of air required, will be more for producing the given refrigeration effect. Now refrigeration effect, all of you are knowing that refrigeration effect we have discussed, that refrigeration effect is the amount of heat removed in order to produce the low temperature or in order to produce the cooling. So in case of air, there are two advantages, that is, it is available free of cost, it is available in plenty, and second advantage is leakage will not cause any harmful effect. Leakage of air from the system will not cause any harmful effect. So what are the disadvantages? Why we are not using the air for the working medium or for producing the refrigeration? So we can say that biggest disadvantage of air is air cannot change its phase from vapor to liquid and liquid to vapor, and that is how the total amount of heat absorbed by the air in order to produce cooling is less, because only sensible heat is absorbed by the air. There is no latent heat portion. So the total amount of heat, that is refrigerating effect produced by air cycle refrigeration system, will be less. So air generally not used for the refrigeration purpose, although by expansion of the gas or by expansion of the air we are getting the lower temperature. And second biggest disadvantage for the air cycle refrigeration system is total volume will be more for producing the given refrigeration effect. That is, if you compare that this much amount of heat that is to be removed to produce the cooling, so if you use the air, the quantity of air that you need to produce the total amount of refrigeration effect will be more, because the volumetric specific volume is high. So all the size of the component, that is whether it is expander or compressor, the size of the component will be very large in compared to other gases which can change its phase from vapor to liquid and liquid to vapor. So size will be more, power input will be more, as large quantity of air needs to be compressed in order to expand. So first we have to compress the gas, that is ultimately by expansion of the gas we want to produce the cooling. So first we want to expand, first we have to compress and then we have to expand. So for the size of the component will be more, because large quantity needs to be compressed, and large quantity needs to be compressed, so size of the compressor will be more, power input will be more. So total overall efficiency, or we can say performance measurement parameter for the refrigeration system, that we will see coefficient of performance, that will be low in case of air cycle refrigeration system. So due to these two big disadvantages, we are going to discuss about the vapor compression refrigeration system. So here also main phenomena which we are going to use for producing the refrigeration is compression, that is compressor included, and that is how afterwards the gas is expanded in the expansion device. So vapor compression refrigeration system, that means vapor means the gas which can change its phase from liquid to vapor and vapor to liquid, it is able to change the phase. So higher refrigeration effect can be produced with the help of vapor compression refrigeration system. Now we will discuss about the main components of vapor compression refrigeration system. So what will be the main components and what are the different components will be included in the vapor compression refrigeration system. So let's see one by one. First will be the compressor. Here for the domestic refrigerator we can use, you have learned about the different compressors. So we are going to use, we can use the reciprocating compressor in the domestic refrigerator, and for the large cold storage plant we can use the scroll and screw compressor. Then condenser is one type of heat exchanger where the heat is exchanged between the refrigerant and cooling water or air. Expansion device in which the gas is expanded, and evaporator is our refrigerator where the cooling is produced. I would like to repeat, these are the four major components. There are another accessories are also included in the system, but these four are the major components of the vapor compression refrigeration system. I would like to repeat, compressor for the domestic refrigerator, generally reciprocating type compressor is used, and for the large plant screw and scroll compressors are used. Condenser is one type of heat exchanger in which heat is exchanged between the refrigerant and cooling medium. Cooling medium may be air or water. Expansion device in which the gas is expanded. It may be a valve or it may be an expansion cylinder. Generally it is valve or capillary tube for the domestic refrigerator system. And evaporator is the space where we want to produce the cooling or we are maintaining the lower temperature, that is evaporator. And why its name is evaporator? Because our refrigerant, that is cooling medium use, working medium use in the vapor compression refrigeration system is evaporated by absorbing the heat from the space to be cooled, that is evaporator, and that's why its name is evaporator, where our refrigerant by absorbing the heat gets evaporated. That is how it is evaporated, and here we are producing the lower temperature and refrigeration effect. Let's see the schematic of vapor compression refrigeration system. So as I have told you, there is a compressor, here is the condenser, this is the expansion valve or expansion device, and this is evaporator. So what is happening first? Here you can see that there is a red line and blue line, and condenser, evaporator. So first the evaporator, from the evaporator the refrigerant has absorbed the heat from the space to be cooled, is again supplied to the compressor where the pressure is increased. So that's why this is a high pressure side. So pressure of the refrigerant is increased, temperature is also increased. So high pressure, high temperature gas from the compressor will be supplied to the condenser. I repeat, high pressure, high temperature gas from the compressor is supplied to the condenser. In the condenser, the temperature is kept constant and it is converted into the saturated liquid. So only latent heat of condensation is rejected. I would like to say here, high pressure, high temperature gas will enter into the condenser. In the condenser, only latent heat of condensation is rejected. So high pressure, high temperature gas coming out from the compressor is condensed, that is converted into the liquid into the condenser by either air or cooling water which is circulated through the condenser. So my gas, that is refrigerant, will be condensed into the condenser. Condense means converted into the liquid. So high pressure, high temperature gas coming out from the compressor is converted into the saturated liquid into the condenser, and condensation takes place by the cooling medium, either air or water. For our domestic refrigerator which we are using in our home, air is used for the condensation purpose. So at the back of the refrigerator in olden days, you might have observed that there are fins on the tube, that is for releasing the heat, so that maximum air can come in contact with the tube of condenser through which the refrigerant is flowing. So air will absorb the heat from the refrigerant in the condenser, and the gas will be converted into the saturated liquid. So we will say here that only latent heat of condensation is rejected. There is no sensible cooling. So ideally temperature will remain constant in the condenser. I will repeat, ideally the temperature in the condenser will remain constant. Temperature of what? Refrigerant. So high pressure, high temperature refrigerant coming out from the compressor is condensed in the condenser by cooling medium like air or water. In the domestic refrigerator as well as air conditioner, air is used as a cooling medium in the condenser. So this is a second important component of vapor compression refrigeration system, that is condenser. Condenser is one type of heat exchanger in which heat is exchanged between the refrigerant and cooling medium. In the cooling medium, it may be air or it may be water. So condenser, the refrigerant gets condensed and it is converted into the saturated liquid. Saturated liquid coming out from the condenser is expanded into the expansion valve. Saturated liquid coming out from the condenser is expanded into the expansion device. This expansion device can be a capillary tube. Capillary tube is a small diameter long tube. You might have seen, all of you have seen the capillary tube. Nowadays with the new refrigerator and air conditioner, there is a thermostatic expansion valve is fitted as an expansion device, but capillary tube can be used as an expansion device in the previously in the domestic refrigerator as well as window air conditioner. But nowadays thermostatic expansion valve is used for expansion. So saturated liquid coming out from the condenser is expanded into the expansion device. Generally it is a thermostatic expansion valve, but capillary tube can be used as an expansion device. So after expansion, here you can see this is a high temperature region, this upper over this dashed line, and this is a lower temperature region. So these two components are maintained at a lower pressure, and these two components are maintained at a higher pressure. So this is a low pressure side and this is a high pressure side. So here after the expansion in the expansion device, the saturated liquid coming out from the condenser is expanded and will be in the phase of low temperature, low pressure, wet vapor. I repeat, it is a low temperature, low pressure, wet vapor, and this expansion ideally isenthalpic expansion at where the enthalpy of the refrigerant will remain constant, Expansion through the expansion device is isenthalpic process, that is constant enthalpy process. Enthalpy of a refrigerant will remain constant and saturated liquid coming out from the condenser will be, after expansion, it is a low pressure, low temperature wet vapor coming out from the expansion device. Expansion process is isenthalpic. Here the low temperature, low pressure vapor coming out from the expansion will enter into the evaporator, and here it will absorb the heat from the space to be cooled from the substance, and then that vapor will enter into the compressor. So here also I would like to mention in the evaporator also the latent heat of evaporation is only absorbed. Here also latent heat of evaporation is absorbed in the evaporator, while the liquid part of the refrigerant will take place in producing the refrigerating effect. I repeat, only liquid part present in the low temperature wet vapor which is entering into the evaporator will produce the cooling. So only latent heat of evaporation is absorbed from the space or substance to be cooled, and then the evaporated gas will enter into the compressor and cycle is repeated. So let's see, the low pressure liquid refrigerant in the evaporator absorbs the heat and changes it to the gas. In the compressor, superheated vapor enters the compressor where pressure is raised. So here I would like to mention that at the end of compression there can be a wet vapor, that can be a dry and saturated vapor, or there can be a superheated vapor. In the condenser, as I have told you, high pressure superheated gas is cooled in several stages in the condenser. That means generally latent heat of condensation is rejected in the condenser. So condensation process will be constant pressure, constant temperature process. Ideally, I repeat, condensation process is ideally constant pressure, constant temperature process. Only latent heat of condensation is rejected by the refrigerant in the condenser, and refrigerant will be converted into the saturated liquid while coming out from the condenser and entering into the expansion device. Sometimes receiver like component is also placed after the condenser. So in that receiver refrigerant is stored just for the storing purpose. Receiver is introduced in the circuit after the condenser where refrigerant is stored. Liquid pass through the expansion device which reduces its pressure and controls the flow into the evaporator. Here this word, controls the flow in the evaporator. That's why as I have told you that between the condenser and expansion device there is a receiver which is placed in the circuit which will store the extra refrigerant, because expansion device is also flow control device. It is not just expanding the gases but it also controls the flow. That's why that is flow control device also, and that's why receiver which will store the extra refrigerant will be placed between the condenser and expansion valve, expansion device, so that the expansion device which will control the flow of refrigerant, extra refrigerant can be stored in the receiver, and then the rest of the refrigerant afterwards it is supplied to the evaporator, and where by absorbing the heat refrigerant is evaporated and cycle is repeated. So I hope you have understood, and let's see the small animation of this vapor compression refrigeration system by a video and try to understand the cycle more in the detail.
So the vapor compression refrigeration system has an evaporator, has a condenser, has a compressor, but the compressor, you want to feed it saturated.
That is compressor, condenser, expansion valve and evaporator. And here temperature entropy diagram is plotted for the vapor compression refrigeration system. Here from the 1 to 2, that is isentropic compression process in the compressor. You can see the isentropic compression process in the compressor. 2 to 3, that is after the compression process, that is entropy remains constant during the compression process, and then it is a superheated compression. So 2 to 3, that is condensation process. At the end of condenser there is a saturated liquid. Refrigerant will be in a saturated liquid form. So at the end of condenser, when the refrigerant is coming out by rejecting the heat to the cooling medium, here you can see the rejection of the heat, and heat is rejected, and so the 3 point will be on the saturation curve liquid line. So 3 point refrigerant will be the saturated liquid, and then in the expansion there is a isenthalpic expansion. So it is denoted by this line on TS diagram. And fourth, you can see the temperature is reduced after expansion from 3 to 4. Here also the saturated liquid, in the schematic also you can see the saturated liquid is expanded in an expansion valve, and at the 4 point the temperature is reduced in the TS diagram, and low temperature wet vapor form refrigerant will enter into the evaporator, where it will absorb the heat. Here also heat absorption symbol is shown. So heat is absorbed in the evaporator by the refrigerant, and saturated vapor coming out from the, here also this point is placed on the saturated vapor line. So the refrigerant coming out from the evaporator is at this point and will enter into the compressor. This was the small explanation of a vapor compression refrigeration system. Now let's see the next slide. What is a refrigerant? What is a refrigerant? That the process we have seen, how the cooling is produced in the evaporator, refrigerant expanded, gets at we are getting the low temperature refrigerant. That low temperature refrigerant we are supplying to the evaporator, and then in the evaporator heat is absorbed by the gas and cooling is produced, that is low temperature is produced in the evaporator, which is a space to be cooled, and we are keeping substance which we want to cool, and that's how the refrigeration is produced by vapor compression refrigeration system. Now in whole these 4 components we have seen, different processes we have seen, that is isentropic compression, constant pressure, constant temperature, condensation process, then isenthalpic expansion, and then constant pressure, constant temperature evaporation process also we have seen for the producing the refrigeration. So through all these processes and from all these components, our working medium, that is working gas, which is passed and it follows the different processes. So what is actually the refrigerant is? So let's see the refrigerant. What is the refrigerant? The refrigerant is a working medium used for absorbing the heat at a lower temperature and pressure by evaporation. That means it gets evaporated after absorbing the heat. So refrigerant basically is a working medium and rejecting the heat by condensing at a higher temperature and pressure. So which type of gas should be used as a refrigerant? So desirable properties. So there are different desirable property by different aspects. So naturally safety aspect. So if it leaks, then it should we should come to know that it is leaking. So there has to be some odor or smell, we can say. With the smell we can predict that the gas is leak, but simultaneously it should not harm to a person which is working. So it should for the safety of the person who are working and safety of the environment also, it should not create any harmful effect. Secondly, it should not be costly. It should be easily available in the market. Third thing is, it should not react with the material of a different component which is used in the refrigeration system. So these are the basic properties, that is safety point of view, cost effective, and reaction. There should not be chemical. Other than this, for the refrigeration itself, there should be a thermodynamic properties which should be desirable thermodynamic properties. That is, it should have a high latent heat of evaporation so that it can absorb the more amount of heat. Good thermal conductivity so that it can absorb the heat. High critical pressure and low saturation pressure. So these are the desirable thermodynamic properties. So selection is based on the various factors. Desirable thermodynamic property to achieve the adequate cooling. It should be cost effective, avoid the hazard, toxicity, environmental effect. So minimize the harm stratospheric ozone layer. It should minimize the harm to the stratospheric ozone layer and reduces the negative impact to the global climate change. And these were the refrigerants previously used. Now new refrigerants are coming due to the global warming potential is very high. These all the refrigerants are having a good thermodynamic property. We will continue in the next lecture, but just I am giving you as we are reaching the time. So we will discuss this thing in a more detail in the next lecture. So refrigerants, which are the different types of refrigerant that should be used, and what are the different types of unit of refrigeration, what are the advantages and disadvantages of vapor compression refrigeration system. So with this vapor compression refrigeration system, we can achieve the high COP and can work in a wide range of temperature range, while the disadvantages are the high initial cost as well as leakage is the problem. If there is a leak, so it is very difficult to repair the leak. So I would like to summarize here. We have learned about how the refrigeration is produced, what are the refrigerators, by what mechanism, what different methods we can produce the refrigeration. So first, definition of the refrigeration, then different methods of refrigeration, why we want to use the vapor compression refrigeration system, what are the disadvantages of air refrigeration or simple air cycle refrigeration system, that we are going to again learn in detail, and why we want to use and why people are using in a domestic refrigerator vapor compression refrigeration system, what are the main components of vapor compression refrigeration system and how it works, that we have discussed. And now in the next lecture we will discuss about the different types of refrigerants as well as vapor absorption refrigeration system and air cycle refrigeration system. So I hope that you have understood this in detail, vapor compression refrigeration system and main components of the vapor compression refrigeration system. Thank you.